I'm the Coffee Crow, and in this series of videos we'll be creating and covering player controllers going from simple to complex for 2D platformers in Godot. Now, there are many different ways of doing this, and the methods that I'm using are not the definitive methods for creating a player controller, but from my own experience are really great to kind of learn and improve upon. Let's actually move into our first player controller, the simple controller. What makes this simple is that it's all defined within one script and uses very little advanced knowledge of the engine to accomplish what we need it to do. This can be created within 10 to 20 minutes depending on how familiar you become with the GDScript language and the Godot engine. We have made it so we can move left and right, handle falling, jumping, and of course play some animations. It's also customizable within the editor so you don't have to fiddle with the code. Now let's actually move into how we can create this. Moving into our editor, you'll see that I've already created a level for our character to bounce around on. We just need to actually create the character itself so we can start applying our simple movement controller. So to do that, the first thing we're going to do is go up here, create a new scene. It's going to be of other node type character body 2D. We're going to need to give it a sprite. Now, how I'm doing this without actually clicking any of the buttons, I'm using the shortcut Control A whilst highlighting character body to open up the create a new node screen. So with that done, we need to add a collision shape and an animation player to finish off building our actual character out. So we need to give our sprite an actual sprite so we can actually see what our character looks like. I'm going to be using the Kenny's Pixel Platformer pack. A link to the website and for this pack specifically will be in the description. They make very good packs for prototyping out different games or different things. It's just very easy to have the art ready for you so you can just jump into the creation. So I'm going to be using this sprite for our character. Now you'll notice two things. One, it's blurry, and two, it's flipped in the wrong direction. It's looking left. We are going to want it looking right because right is going to be our kind of forward-facing direction. Now, to first fix the flip, we need to go into the offset over here and then turn flip H on. I'm also going to change the offset in our X and Y to get this pivot point at the character's feet. So for our Y, I'm just going to set -12. Now that puts our character's feet on what I would like to call the floor here. Now let's fix this blurriness. To fix this, all we have to do is go up to our project settings, go into our textures down here in rendering, change our default texture filter to nearest. Nearest is primarily used for pixel art, and that's what we're using. With that done, we do need to also set up something else here. For that, we need to go to the input map and give our character the ability to actually kind of read inputs, right? We're going to want it to read our keyboard inputs as certain actions. The very first one I'm going to do is I'm going to write move underscore left. The second one will be move underscore right, and the final one will be jump. Now, when designing an input map and adding actions, it's always good to keep in mind that not everybody uses their keyboard and mouse with the same hand. Sometimes people use left hand for keyboard, right hand for mouse. Some people use right hand for keyboard, left hand for mouse. So to keep that in mind, we are going to first go into our move left. We're going to use the A key for our keyboard. And then for people who use the arrow keys, we're going to use the left arrow key. Now we're going to do this with each thing. So the next one is move right. We're going to go D, and then the right arrow key. And then for jump, we're going to use W, space, and finally up arrow keys. So this sorts out our basic input map that we need. With that done and the blurriness fixed, we now need to go into our collision shape because it's giving us a little warning and add a new collider to our character. And we'll be using the circle shape. You can use whichever one kind of suits your character more or suits your kind of art more. In this case, a circle will do for me. I'm going to pull this in a little bit so it's a little bit smaller. Then I'm going to use the move tool to move it up so it's touching, like the very bottom of it is touching the floor, same as our character's feet. This way, the top part of our character, or our character's head, basically can clip through things. It just kind of feels a bit better sometimes. It really depends on how, like, the look and feel you're going for. This done, I'm going to hit Control S. Now I'm going to go and save this scene under our player folder. Actually, let's rename that. I've done this a few times where I forget to rename the character. Now we'll go save it. Right. This is the real basics of our character scene created. I'm going to go into our main scene, into a little container I have here, and I'm going to use Control-Shift-A to open up the Instantiate Child menu. Now I'm going to instantiate the player in here. I'm going to move the player. I'm going to place it just above the ground so we can see things like gravity actually take effect on our character. Now, you'll notice there is probably one thing that I'm actually missing here, and that is a camera. I will go into more detail in a different video about how to set up a camera as its own standalone scene that can be moved about, but for now, what we're going to do is just add a camera, 2D. We're going to change the zoom amount to 2, hit Control S to save, go into main, and see that we now have this purple rectangle around our character. This will be our camera. So if I press F5, you'll see that not only does our character not move, but we do have the camera in the correct place. That's good. Now, let's actually go into our player again. Let's add a new script. We're just going to call it player.gd. I'm not going to be using any templates. If you have some, feel free. I personally don't like using them. I like blank slates. So creating that and moving into our script, we are going to need to first create some onReady variables for our character. The very first one will be the sprite 2D. Now, an easy way of creating onReady variables will be to click on the sprite, drag it over, and before you let go, hold down Control, and then let go of your mouse. This creates an automatic onReady variable, names it, and sets it correctly. Now, you can go further and typecast this as a sprite 2D, like this. This makes sure, or this kind of guarantees that it's typecasted correctly. And now we're going to do the same thing for our animation layer. And once again, you can do the same thing and set it up as a animation layer. Did I spell that right? Yes, I did. So typecasting just makes the engine kind of read this faster. It automatically knows what it actually is using rather than it having to kind of figure it out on the fly. It can help with speed and performance, and it can also stop a lot of random errors that can occur if you accidentally feed in the wrong type of data type. With our onReady's done, let's actually move into our export variables. So to do that, we're just going to write @export var, and the first one is going to be move_speed. And then we're going to typecast this as a float, and then set that equal to 150, like so. So what export is doing is it's exporting it out to our editor. So if I click on player now, you'll see that we have the move speed variable set at our current setting within the editor. This is one of the things that allows us to really modify our code without actually modifying our code. And we're typecasting this as a float. We're going to want float related movement. Fine tuning is really nice to have. Floats kind of allow that kind of incremental. With that one done, let's now move into our next one, which will be our @export var jump _speed. Once again, we're going to typecast this as a float. We're going to set this to -400. I will explain why negative in 1 second. First, we'll go and create one more export var for full_speed. Once again, float, and we're going to set this to +400. Make sure this updates in our editor so we can see our settings. Now, let's kind of talk about how the y-axis and stuff works in Godot. Going up in Godot on the y-axis is a negative value, so for our character to jump up or move up, we are going to want to set this to negative. And setting our full speed, even though we're going to have gravity, setting a full speed allows us to have a consistent speed, and it just makes things feel a lot kind of smoother. So with those done, let's actually set up our gravity. For this, we're going to go and create a const. Const is basically a number that we do not change. It cannot be changed and it will not be changed unless we go into the code specifically and change it. It's going to be a constant. It's going to be called gravity. You'll notice how I'm kind of typing this out in all caps. Consts are really, they're easier to read if they're typed specifically. In this case, typing it out in all caps allows you to sit there and immediately go, this is constant. So we're typecasting this out as a float. We're going to set this equal to 1000. You can set this kind of as high as you want or as low as you want. With this done, we now need to go and move into, if you are using basic templates, you will have a ready function. So if you have this, we are going to move into this and just type in pass. Now, we're just passing the ready function because we don't actually need it. You can entirely, if you want to, delete it. That way, it just isn't cluttering up the script at all. The function we will need to use, however, is our func_physics process of delta. For now, I'm going to write pass. Now, I'm going to give a quick explanation of this because we will be using delta for our next custom function. But to understand what that is, if you hold down Control and left-click on physics process, it will take you to the documentation for this specific function. You'll see here that delta is typecasted as a float, and it's called during the physics process step of the main loop. Physics processing means that the frame rate is synced to the physics, i.e. the delta variable should be constant. Delta is in seconds. So let's go and create a gravity function real quick. So we'll call it func_apply_gravity. We're going to give it a parameter of delta. We're going to typecast it as a float. And we are going to give it a return of void, so we're not returning anything out of it. This, once again, is just typecasting and making sure the machine or the engine knows exactly what we want. So, to apply gravity, all we're going to do is take our character's velocity. So velocity is a pre-built or pre-designed variable within our character body. We're going to take the y part of this, and we're going to go plus equals gravity times delta. So when we actually call this, which is what we'll do here, we'll go apply gravity, then we'll pass in the delta. What this is going to do is apply delta or apply gravity at a constant kind of frame linked rate, right? That way it's heavily linked to your frame rate and it will just stay feeling good regardless. That one done, let's actually set up our movement handler. So we'll type func handle_movement. It will have no parameters, a void return rate. With that named, let's go into creating our first variable in here, which is going to write var movement direction _direction. You can call this moved, just it is entirely your choice what you name it. Personally, I prefer naming things, so the minute I look at them, I know exactly what they are. I'm going to typecast this as a float, and I'll explain why in a second. Set this equal to input dot get _axis, and I'm going to use move left and move right. So what this will do is return our movement left or right as a individual floating variable. Using input.getAxis basically sets it so it can be -1, 0, or +1. -1 in this instance will be move left, 0 will be us not pressing anything, and +1 will be move right. With that done, we need to make sure that when we are not actually pressing anything, our velocity.x is equal to 0, 0. Now, the reason why I'm using a float here is just it forces it to go down to 0 faster than if you were to use an integer, as far as I'm aware. I could be wrong. I just like making sure things are set very specifically. Now, with our character actually stopping, the next thing we want to do is do an if check. So if, now we're going to check our movement direction. We're going to go is less than 0. Because if it's less than 0, then we are pressing our move left key, because this will be set to -1. And if this is the case, we want to modify our velocity dot x, and we want to set it equal to our negative movement speed. Now, to set up the right directional movement, we basically type the same thing, just as a greater than 0, and then we just apply our velocity dot x equals normal move speed. So just this should handle our movement completely for us. Little clean script. Let's actually go and test this first. Before we do, we need to go into our physics process. We need to write down and actually call our handle movement, and then we finally need to call move and slide. Put a new line between these. So move and slide will actually apply any kind of physics interaction that we are coding in, i.e. velocity. It will actually apply the velocity change for us. This is a very key thing. Don't forget this. It can, well, it will just not do anything if you forget this. So that done, let's press F5. You'll see our character immediately falls to the floor because it's applying gravity. Now if we press right, we move left, or move right, and if we press left, we move left. That is our basic walking done. You'll notice that our character isn't flipping. Let's go and do that first. So let's create a new function. We'll call it flip underscore character. No parameters, void return rate, and we'll go into it. Now, what we're going to do is go if velocity dot x, because we only want to mess with our x velocity here, is greater than 0, meaning we are moving right. We want our sprite2d dot flip h to equal true. Now we're going to reverse this. So if velocity dot x is less than 0, sprite2d dot flip h equals false. So flip h is built into the sprite. Used it to flip my character's original looking position like so. Now, one thing to keep in mind is if your character is immediately, like if you have created your own art and your character is actually looking right already, you won't have flip h toggled, which means when you're setting this up, you're going to need to basically change the flip h true false the other way around. That way you're not flipping if you're moving right and looking left, if that makes sense. You want it to actually line up properly. So just keep that in mind when you do this. Now, the way that this gets applied, and this is a bit of an order of operations thing, is we're going to want to do this after our move and slide. Or we're going to want to call it after our move and slide. That is because our velocity will change after move and slide, or as move and slide is getting called. And that's how we're going to tell if our character can flip. So let's, once again, hit Ctrl-S to save, and then load up our scene. Now our character is changing how it's looking. Perfect. I'm going to have a quick talk about how I kind of set up my scripts. I like my onReady variables up the very top, exports just below that, constants just below that, normal variables just below that. Then you'll have your ready function, then a physics process function, or just a normal process function. Then you have some custom functions, so in this case apply gravity, handle movement. And then after those kind of physics-based or things that actually make your character do a thing kind of functions, we're going to have tool-related functions, which will be, in this case, like flip character or anything to handle animations. And then just after that, at the very bottom of the script, I will always have signal-related functions. Those will be the functions that run when it receives the signal. But we won't be going into that. Not yet, at least. Not in this player controller. In a later one, we definitely will be. So, where was I? Handling movement. We now need to move on to handling our jump. So let's go func underscore handle, handle underscore jump. With no parameters, void return, and I'm going to put pass here. So handling our jump should be relatively easy. Our character 2D has some built-in checks or built-in booleans or functions that we can actually use to check certain things. So the very first one is another input function. So if input dot is action just pressed, meaning we have just pressed our button, we're going to want to put jump in. Now we can sit here and go equals true, although this will return true, but if we want to equal this to true just to make sure and guarantee, we can do that. Then we are going to want to add and. The and keyword just says, okay, and this thing at the same time. So our other check will be a built-in function, and it will be called is underscore on floor. Is on floor just returns true or false depending on if we are touching the floor or not. And if we are, so if is on floor equals true, we're going to want to go velocity dot y equals jump speed. And because we've already set our jump speed up here to negative 400, it will move our character up. Now, if you really want to make this easy, like say you're working with somebody and you want to make this easier, this might be a bit confusing seeing a negative sign in here and being like, oh, that doesn't entirely make sense, right? You can remove the negative sign, come down to our jump speed, then put a negative sign here. This way, it looks normal here, but is applied correctly in our jump function. With that one done, we now need to just apply a clamping function to our jump. That way we are falling and jumping at consistent speed. To do that, we're going to use clamp F or clamp float. Clamp will take a variable that we actually want to stick within a certain range, a minimum and then a maximum. So in this case, we are going to want to velocity.y, then we're going to want to set our jump speed and our fall speed. Now we're going to go up just before move and slide after handle movement and call handle jump. Now, removing the minus sign here, I haven't actually tested too much. It should work. Let's go and find out. Yep, works fine. Our character is now flipping, jumping, and falling at a consistent speed. So let's go and jump our character up here and make sure. Yeah. So to show off the clipping, this is what I mean by the clipping. Our character is not completely whacking its head on, like pixel perfectly whacking its head on this, which gives us a little bit more room to kind of maneuver between some tighter areas, right? Like that. If the hitbox or the collision shape was a bit higher, we might bounce off of that and not actually be able to make this jump. So it's just a thing to keep in mind when you're designing levels and designing characters. Now, the final part of this will be adding our animations, right? It looks a bit odd that it's not playing animations. So let's come down to our flip character. Let's create a new line. We'll call it func handle underscore animations. Avoid return. And for now, we're going to put paths in. So we need to actually set up our animations. If you have custom animations and you already have them set up and ready, then you will be able to skip ahead. I will leave a little timestamp in the video. If not, then we're going to go into our animation player. We're going to click animation, new. We're going to name it idle. Animation, new, move, or run, because that'll be easier to kind of visually understand what we're doing. And then finally, animation, new, and jump. So we have our three animations. We're going to start with the idle. So the first thing I'm going to do is I'm going to key in. If I'm going to press the sprite 2D, then I'm going to use this key up here to key in. I'm going to create a reset track. We're going to key in our texture. And then I'm going to go down into our transform and I'm going to key in scale. Now, I'm not going to be using any different texture for this specific animation. What I am going to do is be modifying the scale. So let's modify the scale real quick. At 0 seconds, it's going to be normal scale. Then we'll go at the halfway point. So at 0.5, I'm going to unlock these, and then I'm going to go down into my Y. I'm going to change this to 1.2. Actually, let's do this the other way. 0.8 to kind of shrink my character down. And then for the X, I'm going to set this to 1.2. And and then I'm going to key in the scale again. And you'll see I've got a little breathing animation. To make sure that that bounces back to where we want it to, I'm going to right-click on my original keyframe, hit duplicate with my little scrubber here at the very end. And now if I press play, we have a little breathing animation. Now I'm going to set this on loop. And then finally, to get it looking a bit smoother, I'm going to go down to the interpolation mode, and I'm going to change this to cubic. Cubic kind of rounds it off a little bit more, so it's a little bit bouncy. I like this a lot more, it looks good. So with this idle done, I'm going to reset my track to 0. So if you, this is a word of warning, if you were like, I don't know, here, say at this keyframe where we're completely squished, and then you jump into a different animation, it will keep that transform. So if you hit the reset track, or you reset your scrubber to the very beginning, it will reset our character to its normal state. So let's go and handle the running animation. I'm going to key in the scale to make sure that our scale will reset to 1.1 when we go into this animation. And I'm going to key in the texture. Now, I'm going to change the length of this down to 0.6. We'll go 0.4. Yeah, we'll go 0.4. 0.4 feels a bit better. Now, at 2 seconds, I'm going to key in a texture. And then finally, I'm going to duplicate this final texture like this. So we have 3 keyframes. Right now, it's doing nothing. So I'm going to click on my original keyframe, or my middle keyframe, so my one at 2 seconds. Up here, we need to change our sprite. And now we have a little running animation. This is one that we don't want looping. We don't want to get stuck in this animation. We only want it to play once, or whilst we play or whilst we're holding down a key to move, right? So that's our running done. Let's finalize this with our jumping. Once again, I'm going to key in the sprite. I'm going to key in the scale. And the length of this one doesn't entirely matter. So what I'm going to do is we'll use this blue texture as our starting frame. And okay, like that. Now we will stay in this specific frame until we land and go back into idle or move. This way it just shows a little bit differently that we are in a jumping state. Now, with our animations actually set up, let's move back into our player script. Go into our handle animations. And now we need to really think about how this will get called, like which order these can get called in. The first one is going to be our idle animation. To do this, we're going to check our velocity, just our entire velocity, and we're going to make sure that this equals a vector2 dot 0. Now, the reason why we're doing this is because velocity is a vector2, right? Velocity is stored like this. So we have our x here and our y here. And we want to check the whole thing and make sure that we are not jumping, falling, or moving. So we need them to equal 0. Now, with that one done, we need to call our animation player. We need to call the play function in our animation player. And then we finally need to pass in the animation we want to play. In this case, it will be idle. So this handles our idle animation. I'm going to come up here real quick. After flip character, I'm going to do handle animation and make sure that this is getting played. Control S, hit F5 to run the scene, and see that now we are playing our idle animation. But you'll notice that if I restart this, if you pay very close attention to our character, we don't start the idle animation until we land. And once again, that is because our velocity does not equal vector2.0. Our y is moving. So let's actually go and check for moving, as in moving left and right. First, we're going to check our velocity.x, and we're going to see if it is not equal, and we're going to set that to 0. So if we are basically not moving, we want to play our animation player dot play, and we're going to want to play our run animation. And finally, to check if we are jumping, if velocity dot y is not equal to 0, animation player dot play jump. And this handles all of our animations. Now, the reason why I say we have to do this specifically is this will always toggle if we are, like this will always evaluate a true if we are not doing anything. Like we're not moving, we're not jumping, our velocity is just flat 0, right? Whereas this will always happen if we are moving left and right. At the same time, this will always happen if our velocity is moving up or down. Now, the issue with this is if this comes after, i.e. our run animation comes after our jump animation, we will, whilst we move around in the air, always play the running animation and not the jumping animation. We want to play our jumping animation. So you could check this with another and then velocity dot y equals 0. You could do this to make sure that it only plays when we are moving our x and nothing else. And this might actually be a very good kind of sanity check to make sure. So let's go and give this a test. You'll see we are playing our moving animation, idle, and jump. And if we move in the air, we are not actually playing any other animations. Perfect. This is our 2D player controller done. Now, this is the simple version. I will be creating an entire series about this. In the next video, we'll go into a more complex version of this using some different kind of programming concepts and ways of building scenes. For now, thank you for watching. Make sure to leave a comment for any mechanics you'd like to see built or pretty much anything in general, or if you have an issue, please feel free to ask. Subscribe, see some more, and I will see you in the next video. Thank you for watching.